Hey guys, Mr. Bowman here. Today's learning objective is in yellow and we are learning to apply basic angle properties. Before we get into this, what I'm quickly going to do, well, I have said basic angle properties, and that actually refers to four specific angle properties. It refers to right angles, straight lines, angles around a point, or around a point, and finally something called vertically opposite angles. And in this video, we're going to become very familiar with each of these four scenarios. We're then going to figure out how to apply them to solve problems. And near the end of the video, we're going to try to figure out how can we integrate a bit of algebra to help solve us with certain equations as well. So I've pasted in a diagram, and this diagram relates to the first example, right angles. So I've got a visual diagram, and from this diagram, the little square symbol in the corner there, that tells us that x and y combine to get a right angle. So mathematically, the relationship in terms of an algebraic expression, x plus y is equal to 90 degrees. So if we knew one of these two angles, for example, maybe we know x is actually 50 degrees, we could use that information and that relationship to mathematically and algebraically figure out what y is. So we would substitute 50 in. So 50 plus y was equal to 40 degrees. Oh, was equal to 90 degrees. Sorry, I got a bit ahead of myself. And that means y would be equal to 40 degrees. And the reasoning, so the geometric reasoning, for an example, is really, really important. Without the reasoning, you wouldn't get any marks. But the reason behind that is because right angles, or actually, maybe angles within a right angle sum to 180 degrees. Hey guys, future Mr. Bowman here. I've just realized I've made a mistake after watching the video again. That 180 degrees, that there definitely should have read 90 degrees. So I'm going to get back to the actual video. And that there, I think, encapsulates what that is. So if you've got two angles within a right angle, you know they're going to add to 180 degrees, and that means you can figure out the other angle. That also works. I'll just draw another diagram. If you have maybe three angles, so maybe you know that's 30 degrees, maybe you know that's 10 degrees, you can use that information to find out this. And in our case, we'll be able to use our same reasoning up the top, and we'll be able to figure out, well, that's going to be 90 minus 10 minus 30, which comes to 50 degrees. So I'm going to get rid of that last example, and hopefully you understand the right angles, because we're going to move on to straight lines as well. So we're now on straight lines. Let's copy and paste in the next diagram. So straight lines, we're looking at there. So we can see angle A and angle B both sit within that straight line, which means they are two angles on the straight line. And in terms of the mathematical relationship, like we did before, we can figure that out. So we know that angle A plus angle B is equal to 180 degrees. And that's because they sit within that straight line. And we can justify that with geometric reasoning if we want to, and we'll get to that after the question. But let's say we know that B is actually 110 degrees. Using that mathematical relationship we set up, we can go ahead and calculate A. So A plus 110, well, we know that's going to be equal to 180, which means A is going to be equal to 70 degrees. And in terms of geometric reasoning, we can say that is correct because angles on a straight line sum to 180 degrees. And that there is our geometric reasoning, and that supports our answer. Without those words, our answer is often quite meaningless and won't get us any marks in the test. I just wanted to extend that straight line one a little bit. So we've got a straight line here, and let's say we've got one that pops up here. And we know that this angle here can be represented by 2x's, and that big angle there, oh, actually, let's change that. That can be represented by 4x. So we can set up a mathematical relationship. So we know both of these angles, 4x plus 2x, we know they must add up to 180 degrees. So let's say 2x plus 4x, we know they must equal 180 degrees. We can group these terms together. Well, that becomes 6x was equal to 180. So x would actually be 30 degrees. And if we link that back to our diagram, that means this angle here would have been 60 degrees, and that bigger angle there would have been 180 degrees. And that there would have the same geometric reasoning as above. We need to support that. Angles on a straight line sum to 180, which means x equaled 30 degrees. So what I'm going to do is I'm going to clear this working to make some room for our next step. So I'm going to get rid of that algebra one at the end, and I will copy and paste in the next one for around the point. So the next angle we're going to look at, their angles around a point. Again, I'm going to copy and paste in a diagram, which hopefully can assist our understanding and our description of that. So angles around a point, links to that. And from our earlier video, from our last video, we know angles that surround a point, or angles that go from start to finish, we know combined, they add up to 360 degrees. So in our scenario, we know that A plus B plus C, all of those combined have to come to 360 degrees. And if we throw in some numbers, so let's say we know B is 90 degrees and we know C is 120 degrees, that would give us enough information to figure out what A is. So A would be equal to 90 plus 120, and that came to 360. A plus 210 comes to 360, and finally we can make the claim that A is equal to 150 degrees. So we've used that information to get our answer, and we do need to support that with geometric reasoning. The example I would like to use, so angles around a point sum to 360 degrees. And I think for me that really wraps it up quite nicely. And it does work, so maybe let's draw in another example. So let's say we've got a lot more angles. So let's say that there is x and that there is x. Let's say that's 2x and that's 2x. And let's say that's, I don't know, maybe that's 3x and maybe that's 3x. So again, we can figure out the value of x for all of these because we know all of them added up together need to be 360. So x plus 2x plus 3x plus x plus 2x plus 3x, we know all of those should have combined to get to 90. In total there, that was 12 x's, which came to 360, which meant x was equal to 30 degrees. So we could go ahead and figure out, well, that one there was 30 degrees, well, that there is 60 degrees, that there is 90, that made that 30, that's 60, and that's 90 as well. And the same reasoning would apply. You'd have to support your answer with a nice statement, but you'd support it with a similar one that we got over there. Angles on a point sum to 360 degrees. So again, I'm going to clear our working, and then once we've done this, we'll be able to get into our final angle rule, vertically opposite angles. And this one is a little different to the other three. And what I'm going to do is I'm going to copy and paste in a picture, and I'll be able to explain why. Okay, so let's paste in our last video, And we'll change pen color to finish up. So we'll start using the pink pen. So what we're going to do, vertically opposite angles, well, that relates to that diagram here. And this one, I think, conceptually is a lot easier than the other ones. So what we've got in this diagram is we've got one line intercepting another line. And what vertically opposite lines tell us, so what we can do is we can see A and B, they are both opposite to each other, and the angles going the other way. So let's maybe we called that one C and that one D. Those two there would be opposites. Angles A and B are actually going to be equal to each other. So angle A is equal to angle B. So that means if we knew, say, angle B, let's say that there was 85 degrees, we could put that in, and straight away we'll be able to make the claim or be able to say that A was equal to 95 degrees. And we'll be able to justify that by saying vertically opposite angles are equal. And that there's enough evidence to support that. We can even go the next mile. Again, we can link in some algebra. So let's say, let's get rid of all that. So let's say angle A is equal to 2x plus 3. And let's say the other angle is 47. We'll be able to mathematically figure out what 40 or what x actually is, because we know A is equal to B, which means 47 will be equal to 2x plus 3. If we continue solving that, we know that 44 would be equal to 2x, and then that there would reveal that x was equal to 22 degrees. And we'll be able to support that answer for x because vertically opposite angles are equal. So hopefully you found this video useful. We went over the 4 basic angle rules. We learned about angles in a right angle, summing to one. Oh, whoopsie daisies, I just realized a mistake. So if you are going through this, that there is definitely 90 degrees. We've also learned that angles on a straight line sum to 180. Angles around a point sum to 360. And finally, we learned that vertically opposite angles are equal.